Hey YouTube, figure I'd ramble on for a little bit about my Precision Matthews PM-940m, which I converted to CNC. Give a high-level overview of what's going on, how I've been using it, how it's been doing, and just kind of a overall on what this machine is now. So it started life as a Precision Matthews 940M. I think that's the M. That's the manual. It's before they released the belt drive. But I did the easy button and I bought a ball screw kit from a guy on YouTube who runs a business, but he goes by ArizonaVideo. Guy's name is Dave, and he's pretty much the expert on these DIY style CNC conversion kits, and it was really, for me, the easiest and most straightforward way of doing this because I didn't have to measure it, and he offers it for a very good price. I think he still offers it, I'm not quite sure, but the mill after the conversion has 28 inches of travel in the X, and it goes faster than that. Let's do this. There we go. .28 in the X. So that is a little over 12 and a half in the Y. I'm lying, 11.65 inches in the Y. And it's limited by, not the machine itself, but limited by clearance to the vise. So I took off a little bit of travel in order to run the vise all the time. And it's got 15 inches in the Z. X and Y travel speed is 300 inches a minute rapids. Z, it is 100 inches a minute, and I did 100 inches a minute versus 300 on the Z mainly because this head is almost 250 pounds, and I just wasn't. I don't think the servo is really happy pushing that much weight around that fast. So speaking of the servos, the drive system it's controlled by Centro at Acorn. I'll go into the electronics box a little bit later, and that is controlling some DMM servo drive, or DMM, don't know their exact name, but they're 750 watt or 3/4 horse servos on X, Y, and Z. I also installed a one-shot oiler which feeds into multiple different distribution blocks, and it basically oils X, Y, Z ways and their individual ball screws. So for the head, or for the spindle side, let me be a little more accurate. Let me just turn that off. The mill originally was a gear-driven spindle. It topped out at something with less than 3,000 RPM, which for CNC purposes is very little. So I converted this mill to a belt drive, and this is kind of my own fabricabbling, but it's now driven by a 3-horse, 3-phase motor, which has it overperforms the 3 horsepower by a lot. I've been pushing this motor pretty hard, and just watching how many watts it pulls from the wall, it spikes up to almost 6 horsepower. But so it's a belt drive conversion, and it's 1.5 to 1, which means that I get 8,000 RPM out of a max of 5,400 RPM from that motor. So 8,000 RPM is much better for just aluminum milling and small tooth milling. I also installed this 6,000 count encoder, driven 1-to-1 off the spindle, which lets me do rigid tapping and all that stuff. Lastly, I made this power drawbar, which works in conjunction with the Tormach TTS collet system. I guess that's redundant. The Tormach tool system would be the right thing, and it's essentially a, I can do this kind of one-handed, let's see, but it's essentially, it's supposed to fall out, but I can't grab it with one hand. It's just, I'll just use a different one. It's a 3/4 inch collet, and it grabs this precision ground 3/4 inch shank with a known stop. So basically gives you a very repeatable system of tools. So that one goes out, this one goes in, it all references off this bottom face, and I could have reference tools. The power drawbar is kind of the standard way of doing a power drawbar for these. It's similar to what Tormach does on their machines, or their now earlier machines, not their MX series, but it's essentially a regular drawbar which tightens into that collet, and it preloads these Belleville washers. When you activate the spindle, it compresses those Belleville washers, taking pressure off the drawbar, and releases the tool. To take the pressure off the Belleville washers, I have this pneumatic air cylinder, which is a 3-stage 100 millimeter diameter stage pneumatic cylinder, and it's fed by 100 psi of air pressure. Doing the math and division and the multiplication, this is able to push down with a little bit more than 3,500 pounds of force. So I tighten this drawbar so that it preloads these Belleville washers, just less than 3,500 pounds of force. That way this cylinder can overcome the pressure by squeezing those Belleville washers, and that's releasing the tool. Closing this up. Inside the spindle, I changed out the bearings in the spindle itself to angular contact bearings, which are able to live basically at 8,000 RPM for the tool speeds. I'll just give it a spindle. So the RPM range on the low end, that's below 100. That's 88 RPM. 3,700, 3,800, 5,000, 6,700, 8,000. And I have that encoder on there, so I'm able to monitor and control the speeds pretty accurately, which lets me do rigid tapping and all that good stuff that an encoder on the spindle lets me do. So moving on from the general mill, I made this enclosure for the whole mill. It lets me do flood cooling and chip evacuation, all that good stuff without getting coolant all over my shop. Essentially, it's a big aluminum tray that I welded up. It contains the whole mill, all of it inside. And then it has a 80/20 frame that is built into the inside of it with panels for the rest of the enclosure. And goes all around. On the back, I added a service panel, which is right now removed, so that I'm able to get to the back and adjust the oiler, service this back screw, whatever I need to do, access all this good stuff back here. The mill is sitting on a welded steel base, which I fabricated out of 3x3 by 1/4 inch thick tube. And this tube is then filled with sand to give a good vibration damping. I remember I weighed this stand, and it's just shy of 1,000 pounds. which brings the whole setup, the whole mill setup, to about 3,000 pounds with everything that I have on it. Inside this stand, I have my flood cooling system, which, as you can see, it's not pretty, but it works. But a high level of that is I have a 30-gallon coolant tank, which it's the reservoir catch. It has a chip tray directly over top it with some mesh that's able to catch any chips that leave the enclosure and come down here. There is a 1/2 horsepower pump motor on it, which takes coolant from the bottom of the tank and basically pumps it through this, I want to say this is going a little bit, 100 micron filter, and up to the mill up there. I'm able to set the pressure with a bypass valve, which if I bypass all of it, essentially 0 psi of pressure goes up towards the mill. If I close off the bypass, all the pressure goes up. I generally run this mill at about 25 psi of coolant pressure, and it's a significant amount of flow. I don't have the exact number of how many gallons per minute, but it's a lot. It will dump that whole tank very quickly if you do something wrong. All of this is my skimmer setup. Essentially, because this is a give and weigh style drive system, it needs to get oiled by the one-shot oiler, and all the oil falls down into the tray and eventually winds up in the coolant, and you don't want that to be kind of in the coolant, so oil flows to the top. I have this little oil skimmer, which just, this little belt basically pulls up any oil from the coolant, dumps it into this little tray, and it goes into this tank. This tank is a secondary coolant oil separator. Essentially, the skimmer pulls a little bit of coolant with the oil. It's not perfect, and what this does is it's a tank full of coolant up to about here, and then everything on top is the oil that it pulled. This drain goes all the way to the bottom of the tank and it's sitting in coolant. This drain pulls off the top of the separator. So essentially, as oil and coolant fall in here and this level wants to rise, the oil floats to the top, the coolant floats to the bottom, and as the oil sits on top, it comes out of this drain and drips here. When it comes to a certain level, it comes out and the oil drips out of here. The coolant comes, as it falls down, goes to the bottom and goes into that tube and gets pressed out the bottom of the tube, and the coolant comes out here. So I'm able to recycle my coolant and not waste it. And I'm just take this extra coolant, dump it into the tank. Life is good. So for the controls, like I said, is centered Acorn. We have. I went with this a little bit pricier option over Linux CNC or Mach 3 and all of that stuff, mainly because it works. It's a very reliable system. It's able to run a ton of code. It's got, I mean, basically anything you would see on a real CNC machine, as real as this is. But yeah, it's a professional grade software and very little messing around. The way Centroid works is there is a control PC which then feeds code to the actual control board in my control box, and I have this control PC mounted on this pedestal, I don't know what to call it, but this PC mount. It's a touchscreen monitor, which lets me access all of this. Plus I have the keyboard and the mouse if I actually need to use it. I have my basic controls, lights. I got my USB port, safety. I got wireless pendant if I need to control anything in here. Which is well worth it. If you guys are building one of these and you're not sure whether you want to spend a few $100 on one of these things, you want to spend a few $100 on one of these things. That is, yeah, one of the best investments you can make for a mill. But being able to just crawl in here, do whatever you want to do without any wires, wherever you want it, this thing is priceless. And this pendant itself is sold by Centroid, and it works directly with their software without basically any setup work. It just works. For the electronics, they're mounted here on the side. Essentially, you have the Centroid Acorn board, some relays, you have the DIN2 drives for each servo motor. I have an Automation Direct 3 horsepower VFD, which again, I've seen way higher spikes than 3 horsepower, but it works. And the way this electronics enclosure, it's fairly small, so I had to kind of be creative with the space, but this level on top is my IO kind of PC side. This is the actual kind of brains of the operation. Underneath there is all the power supplies, and I have a 24 volt, a 60 volt, a 5 volt, and that is it. And the 240 volt coming in. I have my outputs over here. These are my switched 110 volt outputs, which drive everything from the lube pump to the oil pump to lights, all that good stuff. And up here I just have a tiny little power relay, which lets me kind of keep an eye on how much power stuff is being used. Oh, look at that, 6669 now. Almost used the devil's wattage. And obviously all my outputs for my different axes. So that's kind of the very high level, rambly overview of what this mill actually is. To show it kind of operate, or at least show the coolant system, I need to go put that panel back on the back. Otherwise coolant's going to go everywhere. So I'm just going to take a second to put that panel on, and then we'll take it from there. Alright, I'm back. So I put the panel back on. Show you. Panel just basically covers this back exposure. It's all attached on these wing nuts and studs, but it does not leak. Coolant doesn't really come here when it works, and this is a really easy way to be able to get in there, touch up anything that I need. The Z motor is up above the mill, so I could easily use it, and the whole top of the mill, you can see I use it as storage. It's very convenient. I'm in a small space, and it's giving me plenty of storage up here. So next thing I kind of want to show is the flood coolant, which comes from down there, goes through the pump, goes here. Close the doors, otherwise I get douched in coolant. It needs to prime itself. There it goes. And I always just clean the mill so not everything points to where it needs to go. But this flood coolant is 25 psi before the filter, which is about 20 psi after the filter. The filter basically gets out any kind of crap that doesn't get caught by the chip tray. It does a pretty good job. I mean, 5 psi drop across the filter is pretty much what it always does, clean or dirty or whatever. But I'm very happy with the enclosure and how it keeps all the wet in there. Apparently I need to clean out a little bit of the jets because a couple of them are clogged. This mill hasn't been running for a little bit, and when it does that, a little bit of the coolant I guess it's bacteria in the coolant that starts to plug things up, but it's something I need to clean out. And that's with the spindle going at 6,000 RPM, roughly. Still very clean, very contained. And apologize how dirty the windows are, but there's just no way to keep everything clean. And yeah, that's the coolant system. So I think I'm going to stop the video there because I don't have a part set up to show you how it cuts, but I have other videos on my channel. But that's kind of the high level overview of my converted PM-940. Hope that this didn't come out too rambly. I'm not really good at long videos, and I tend to forget things when I'm just talking at a camera. I feel like I have the memory of a squirrel that got dropped on its head as a kid. Not that good. So hopefully some of this made sense. Otherwise, yeah, I guess I'll just have to make another video. But yeah, thanks for watching.